Siluria is a company dedicated to producing two products from natural gas, ethylene and liquid fuels, including gasoline, diesel, and jet fuel. According to their website, ethylene is the most widely used petrochemical and is used in plastics in packaging, medical devices, automotive parts, and many other applications. The company strives to provide an alternative form of ethylene production and liquid fuel production.
Liquid fuels are currently produced using the Fischer-Tropsch process. It is a multi-step path that consists of stream reformation reaction under high temperatures to form syngas, followed by stoichiometric adjustment and conversion to produce liquid hydrocarbon fuels, including diesel and gasoline. However, high-value chemical intermediates such as ethylene are not formed. Currently, ethylene is produced through thermal cracking of naphtha, an oil derivative. This process is expensive because of the high cost of the raw oil material and because cracking is an energy-intensive process.
Siluria, on the other hand, can accomplish both the production of ethylene and low-cost production of liquid fuels. They first use a reaction called oxidative coupling of methane. Natural gas and oxygen are fed into the reactor, along with an optional ethane feed. Ethane, methane, and oxygen react over a catalyst to produce ethylene, water, hydrogen, and heat. The exit stream of the reactor can then be purified to produce ethylene. Methane and ethane are recycled, and heat is used to produce power. Now, ACM is not a new idea. It was first proposed in the 1980s by Keller and Basson. However, their metal oxide catalysts resulted in only 15 to 25% ethylene yield. Siluria took on the challenge of developing catalysts to make OCM a commercially useful process. OCM not only uses cheaper materials compared to crude oil, but also reduces energy costs as the OCM reaction generates energy, which can be used to power the plant. Unlike the Fischer-Tropsch process, Siluria's process allows for the purification of an important intermediate, ethylene. This can be purified for use in plastics. If the desired product is liquid fuel, the exit stream of the OCM reactor is fed to the ethylene to liquid reactor. ETL is another catalyzed reaction consisting of catalysts selected for the specific liquid fuel. These fuels are then purified, and the excess methane and ethane are recycled to the OCM reactor.
Other large petrochemical companies, including Union Carbide and Arco, have tried to develop the OCM reaction but have not succeeded. However, Siluria was founded in 2008 and is the first company to develop a commercially viable process to convert natural gas to ethylene, which is then converted to gasoline. Siluria Technologies has developed a system that produces gasoline for a consumer price of $1 per gallon, whereas existing companies sell crude oil-derived gasoline for approximately double the price.
In 2014, Siluria partnered with a company called Braskem, a producer of ethylene and thermoplastic resins. Siluria opened an OCM demonstration plant at Braskem's site in La Porte, Texas. Siluria does not currently manufacture products, but is in communication with various companies. We now focus on the most innovative unit operation, the oxidative coupling of methylene reaction. This company uses a single-step process to convert natural gas to ethylene using the oxidative coupling of methane reaction. The reaction begins with methane, ethane, and oxygen as inputs and produces ethylene, water, and heat. Siluria began with catalyst development. They systematically tested hundreds of metal oxides based on published research and expanded into other catalysts, including sulfides and nitrides. They then experimented with different nanowire formations of the catalyst. Siluria's novel approach to using polycrystalline nanowires allows for rapid, more efficient selective OCM. Siluria claimed in their recent 2012 patent application that their novel nanowire OCM catalysts have yields ranging from 20% to 90%, with ethylene selectivity upwards of 90%.
While their catalyst does optimize efficiency and selectivity, the company sought to maximize ease of use of the catalyst. It operates at temperatures hundreds of degrees lower than already published catalysts, and at lower, more practical pressures, 5 to 10 atmospheres. In addition, the catalyst is flexible to ethane, methane, and oxygen composition in the feedstock, which reduces operating costs of the plant.
In conclusion, Siluria shows more promise as a company. They have received a total of $150 million in funding and have been given many awards, including being named among the 50 smartest companies by the MIT Technology Review. They are currently looking forward to producing a wider range of petrochemical derivatives from natural gas.